Hello, everyone. I'm Zach with Vanlife Outfitters. We are here to help DIY van builders with our blog and our content and our new store. Today, this video is all about Webasto heaters and using them in a camper van. We're going to get into many of the common questions around installation and the controversial, let's say, high altitude mode, and just generally how to keep your Webasto heater running well. I'm joined by Scott, who's the president of VMAX, and VMAX is our fulfillment partner for all things Webasto. They've been selling Webasto products for over 20 years, which is pretty impressive. I'm also joined by Tracy, Pop Special. Did I screw that up already?
You got it. Good enough.
Pretty good. Okay. All right. And he is a Webasto tech who actually works for Webasto, and he trains certified installers. So Tracy is a true expert on these heaters and literally knows them inside and out. So we're going to get into the questions in a minute here. But first, I wanted to talk a little bit about Webasto warranty, because there is a myth on the interwebs that DIY installation of these heaters voids the warranty. And my understanding is that was true some years ago, but is no longer true. However, where you purchase your heater does matter a lot in terms of the value of that warranty. Not all distributors who sell Webasto will fully support DIY installations because it's hard to do that and it can be risky for them. So that unfortunate truth, or that kind of situation where if you buy it from some particular retailers or distributors, you don't get the support that you might expect or hope for a DIY install, is something that we really wanted to address on our store, which is why we're working with Scott from VMAX. And you can be assured that if you purchase through Vanlife Outfitters, you're going to get full support for a DIY install. So with that, Tracy, do you want to maybe do a quick introduction to yourself and what you do at Webasto?
Sure. So I've been with Webasto, I guess, in one way, shape, or form since about 2005. Currently, my primary role is technical documentation, but I am also a trainer. And when needed, I'm actually on the hotline to field technical calls. And we, generally speaking, each person tries to do all the product. So, one call may be a marine air conditioning unit. The next call may be a heater in a Sprinter van. And the next one may be a heater in a off-highway piece of equipment. So we try to be a jack of all trades. The good thing is, the heaters, they all work for the most part in a similar fashion. So we can certainly pull information from one to the other. And also we lean on our other guys. There's a team of 6 or 8 of us. Can't think right now, 6 or 8 of us. And we absolutely will pull somebody else into a phone call if something is maybe a little bit outside of our area of expertise or something we're not sure about. So if you call our tech support line, you're getting full frontline support.
Okay, awesome. Thank you. So a lot of van lifers who use Webasto heaters, specifically the Airtop 2000 STC, are very concerned about carbon buildup, since some people have reported the need to clean out their combustion chamber after only a year or less. So what advice would you give someone who's using an Airtop 2000 to prevent carbon buildup? And is this just something that people should be concerned about at all? Or is this something that maybe is kind of out of proportion with the amount of concern that's out there?
I would say, as far as what to do about it, follow the instructions in the owner's manual. That really tells you about the only maintenance you have to do. And I think we're probably going to talk about this a little bit more as we go forward. But the only maintenance you have to do on the heater is to run it every month for, the book says 20, I like to say 30 minutes on high. So what we specifically mean is when it comes to full load, that's when you start that 20 or 30 minute, timer to make sure it's running for that time. And the reason is there is twofold. The monthly frequency is to keep the fuel pump, the fuel lines full of fuel, keeps the burner mat wet with fuel. So the heater is always ready to go next time you turn it on. And then the duration, the 20 or 30 minutes, that's what it takes to get the burner up to temperature, and that promotes a clean burn. If we call short cycling it, or if you're running it on low a lot all the time, then yeah, it's going to promote carbon buildup, and that's just a byproduct of combustion. It doesn't matter if it's a diesel engine, a gas engine, or a diesel fired heater. So run it for that 20, 30 minutes. I also tell people, anytime you turn the heater on, unless you absolutely can't, run it for at least that 20 minutes and run it on high as much as you can. So in a van, a Sprinter, Transit, ProMaster size van, you're insulated. First off, there's a bunk, garage space, cabinetry. There's a lot of cubic feet you're actually not heating. So suddenly that heater, it may almost be oversized. So I tell folks, open a window or two partway, open a roof vent, even turn a roof vent on to let some of that heat out to make the heater work harder. They actually do have a longer life the harder they work, because the burner chamber stays hot, which means it stays clean.
Interesting. Okay. So when you say run it on high, if I've got the standard reset controller, does that mean I just turn it all the way on? Like, let's say I'm in Florida where, it's pretty hot, probably don't need to run the heater every month. Can I actually make it run on high using the standard controller somehow, even if it's like sort of warm in the environment?
Yeah, so what I mean, and I'm glad you asked that question, helps clarify. What I mean really is when the heater is working, when it's on, you want it to be working. So if you put your rheostat, let's say 12 o'clock, which is roughly 70, 72 degrees, if you have a window or two open or a vent or two open, it's going to have to work harder to get to and to maintain that 70 or 72 degrees. So yeah, don't turn it to the full 104 degree Fahrenheit asking point, because you'll be pretty miserable. Your heater will be clean, but you'll be miserable.
Right. Yeah. And in the context of like, being in a warm climate, how can you run it at full blast? Is that something you can do? Like, say it's the ambient temperature is like 80 or 90 degrees. If I do turn it all the way up, will it actually do that?
If it's 80 or 90 degrees, probably not, at least not for very long, because it will come on high. Let's say you turn it all the way up. So you're asking for 104 degrees. It'll come on high, but it'll get close to that 104 pretty quick. Right. And as it approaches 104 or whatever your set point is, it'll begin to back off. So I tell people, as crazy as it sounds, maybe turn the AC on in the van to make it work that little bit harder.
Okay. Yeah, so that it does make sense that you need to kind of really run it from time to time to clean everything out. And so like my van is sitting in Colorado right now because COVID and lots of other things. So when I get back to that, and I haven't run that heater for many months, should I run it longer on full blast or just do the same procedure to kind of get it back into play?
Really just do the same procedure. The only real issue with sitting is the fact that when you go to start it up, it's going to take longer to start because the fuel lines will have drained down. The sitting won't really hurt the burner. So yeah, you're going to turn it on and let it go through its cycle. Yeah. Eventually, if it doesn't start, it stops. Now, one thing that may happen, if it's been sitting a long time and you go to restart it, and it starts multiple times, it can go into a lockout condition.
Right.
And if that's the case, the way to get out of a lockout condition is to turn the unit on, and then with it turned on, pull the fuse, or if you can't get to the fuse, disconnect it from the battery or unplug the heater main connector, whatever you have to do to take power away from the heater with it turned on, and then count to 30. And the 30 is pretty critical. We're waiting for capacitors inside to drain down. So the control unit is truly in an off state. At that point, turn the unit off, reapply your power, put your fuse back in, and now it's going to be out of the interlock state and it'll be ready to try to start the next time. There's a possibility if you have a really long run of fuel that you'll put it into lockout again, just repeat the same procedure. But typically on a vehicle the size of a Sprinter, Transit, you might put it into lockout once, maybe not.
Yeah, that's a really good tip. I had to do that actually when I first installed it, right? Because the lines were not primed with the gasoline in this case. So that's a really good procedure to know about. Okay, so let's move on to probably what's going to be the main topic of this conversation, high altitude mode. We know that there's a high altitude adjustment that could be made on the Airtop 2000 heaters. And we actually have the workshop guide that describes the process for entering and setting the high altitude mode adjustment, which we can link to from this video. You can find it on our webpage, but it requires like some specific knowledge, and it requires you to have a carbon monoxide meter. So it isn't necessarily like a customer friendly, easy process. So because of this, a lot of people are kind of recommending that you set your heater up in high altitude mode. That is what somewhat kind of arbitrary adjustment. So the question in all of this is, when should high altitude mode actually be used? When is it necessary? And is there like a particular like elevation in which it becomes really essential to use high altitude mode? And if there is such a criteria, is there also some kind of a time horizon where if you say, if you're above a certain altitude and you're going to be there for many days or many weeks or many months, you should do this. And in other cases, you shouldn't do it or don't need to do it. So maybe you can just kind of talk to that, when you should use it and when it's not really necessary.
Okay, so I'll just kind of clarify some terminology. There really isn't necessarily a high altitude mode or even a high altitude adjustment per se. It's really just adjusting. There's an adjustment with a limit, which we'll talk about. The Airtop 2000 STC, for instance, is good for up to 4,900 feet above sea level. And when I say is good to, that means it will produce 100% heat output up to 4,900 feet above sea level. The Evo 40, which is another popular Vanlife heater, is 7,200 feet above sea level. So as far as when to adjust it, the heaters are adjusted when they're built, and that is, if I remember correctly, about 500 feet above sea level. So that's where they're dialed in. So technically at 501 feet, you're starting to run just a little bit richer because there's just that little bit less oxygen. 100 feet doesn't make a difference. So what I tell people to do as far as what altitude, there isn't really a number. So I tell people, look at the exhaust pipe. The heater shouldn't smoke. Now it'll smoke a little bit at startup. It'll smoke a little bit at shutdown because it turns the glow plug on at the beginning and at the end to clean out any unburned fuel. So you'll see a little bit of light smoke at the beginning and the end. Occasionally, possibly you may see a little bit for seconds during its runtime. That's just another mode it goes into. But if you're seeing just kind of a constant light stream of smoke, that says your heater isn't running optimally, and then you're going to want to adjust it for altitude. But if you're going to be at a higher elevation, let's say you're going to be camping at 4,500 feet for a few weeks, I wouldn't sweat it. When you get back down to the lower altitude, run it for a few hours overnight, as high as you can get it to run, because that's going to, again, it's going to get hot and it's going to burn out any carbon that may have accumulated in the burner. So yeah, that's a tough one because unfortunately there isn't a set of rules or a set of numbers I can give you, except for that it'll run at 100% up to 4,900 feet for the STC, 7,200 feet for the Evo 40 and 55. Above that, you're not going to get 100% output. And yes, as far as adjusting, you do need an exhaust sniffer of sorts. There's a lot of different types out there. So what you're going to do is at that altitude, you have to adjust it at the altitude. And if I'm getting ahead of myself, let me know if you have other questions about this coming up. But you want to adjust it at altitude because it's a live adjustment. You're actually using a meter to sniff the exhaust right now. And then you're going to adjust it for that altitude. So a lot of folks they think, well, I can just arbitrarily adjust it, to a certain setting, maybe put the rheostat at 10 o'clock or 8 o'clock or whatever. And that's good for X thousand feet. It doesn't work like that. Again, it has to be a live adjustment. So yeah, take it to altitude, have the meter. If you're using a rheostat, you can do it yourself, and you can call our tech support hotline and we can walk you through it if you need to. We're more than happy to do that. to get it adjusted. But again, only if the heater is going to be staying there. We say living at altitude. I do know at least one person that spends roughly 6 months in the mountains and then roughly 6 months down closer to sea level. So he bought a secondhand exhaust meter and he adjusts his once when he goes up and then once when he comes back down.
Okay, so anything beyond you said 4,900 feet for pretty extended periods of time, it might be worth considering that changing this and setting it correctly at the altitude that you're going to be at specifically. But you do need the exhaust sniffer, or I guess it's a carbon monoxide detector. Is that right? Kind of.
Yeah, exhaust gas analyzer. There's a few different names for them. Yeah, because you do need to read what's going on with that's the only way for you to really know what's going on inside the combustion chamber. We know, of course, you're not getting enough oxygen to keep the proper ratio, air to fuel ratio. So you need to adjust for that. And then one thing I wanted to mention too about the adjustment is, we say the heaters are designed to put out their 100% output up to 4,900 feet in the case of the STC. That's for the STC diesel. We do not recommend running the STC gas above that 4,900 feet. Gasoline, it's just the nature of the fuel. Diesel is a lot more forgiving than gasoline. To not get too deep into the technicalities of it, but I know a lot of Vanlifers do it, or DIY folks, so I'll mention this. When you're adjusting for altitude, you're slowing down those pulses for the fuel pump that I'm sure we're all familiar with, that tick, tick. So the control module knows each one of those clicks, each pulse of the fuel pump is going to deliver a certain amount of fuel, which is going to deliver a certain amount of heat energy. So when we're adjusting for altitude, we're slowing that pulsing down, and gasoline burns very quick in comparison to diesel. So the gasoline, when you start getting very slow, the pulses can't come soon enough and the flame burns out. So diesel is just more forgiving again at altitude. So we don't recommend gas heaters above that stated 4,900 or 7,200 feet, unfortunately.
What's the consequence if you do run it above a gasoline heater above 4,900 feet? Excessive carbon?
Yeah, excessive carbon. Yeah, unfortunately, we've seen it. Unfortunately, more than once. It's just something that it's the nature of the beast. It's the physics involved with the burn rate of the gasoline versus the amount of oxygen at altitude. We have had some people that have adjusted their gas heaters for higher altitude, and what they're really doing is think of it almost like a window. They're adjusting the operating window up a little bit so that maybe they've gained a little bit of altitude, although I don't know how good that's going to be long term, but they're losing on the bottom end. Then the heaters are having a difficult time starting at lower altitudes just because there's only so much adjustment that can be made, and they're trying to make the heater work outside of what it was engineered to do. If somebody is really married to gasoline and they want to get above that 4,900 feet, they want to get some more altitude, we usually recommend the Evo 40. Now, it's a larger heater, which is good and bad. The way it can be bad is your heater really does need to be sized properly. And again, I talked about the fact that in a van, you have a lot of cubic feet you're not really heating. Well, now it's just compounded with the Evo 40 being a larger heater. So then you're definitely going to want to open up a window or two. You're definitely going to want to open up, maybe even turn on a roof vent, pull some of the heat out. So when the heater's on, it's working hard. Because again, a hard working heater is going to be a clean heater. A clean heater is going to last a lot longer for you. So that's our recommendation there.
Okay, wow. So yeah, that's going to be big news for a lot of people who are using the Airtop 2000, who thought that they could get away with some kind of an altitude adjustment. But really, if you're going to be at high altitudes for really longer periods of time, you probably need to step it up to a different kind of heater, an Evo 40 or something along those lines. Okay.
Yeah, that's what's going to give them the most satisfaction. It's going to give them the reliable operating characteristics, the longer running characteristics, just because they're working within its limitations.
Right. And this would go some distance in explaining why people who are using the smaller 2000 Airtop heaters have had some issues with carbon buildup over time, because they may be using those at high altitudes beyond the 4,900 feet. I'm sure there's a margin, right? That's not an exact science. You might be able to go to 5,200 feet or whatever for a while. Would how long do you think, like, let's say you were using this heater in the high country of Colorado in the mountains, like how many months or years would it take for you to see the impact of that carbon buildup on the heater?
Okay, so
Roughly.
I'll give you a good example. Now, this doesn't really matter, but it's a different heater. It's a diesel heater, but this gives you an example, two extremes for carbon buildup. We had a customer that called and he wanted to bring his heater by. He had it's a dual top heater, but it's functional wise, it's the same heater inside. He wanted to get a burner replaced simply because he figured it's time. He had the heater installed for a number of years. It's time. So he brings it in the shop, and first thing we do is we look up the diagnostics. We hook up the diagnostics to it, and he had just shy of 19,000 hours and had never had anything opened. So we said, oh, and it worked great. The heater fired up first time, ran great. And he said, no, just replace it. It's time, just replace it. So we replaced it, and we pulled the burner out, and it was good. It looked fine. Almost 19,000 hours.
Wow.
The converse of that was I was at a customer's facility. He had now same heater, dual top. So this is apples to apples comparison. And he says, my heater won't work. It's my demo heater. So it was on a bench. I couldn't hook up diagnostics at this point. So I took it apart, and it looked like somebody before me disassembled the heater and filled it with beautiful, perfect fine carbon, and then reassembled. It was full to the brim. So we cleaned it out, replaced the burner. And then I looked at the hours. It had 7 hours. But he would turn the heater on as a demo for a customer. As soon as they could feel warmth coming out, they would turn it off. So it never got to normal operating temperature. The fuel never got completely burned out of the chamber. Whereas the other gentleman, out of his almost 19,000 hours, I want to say, when we look in the diagnostics, we can see the total runtime, how it's broken down into 1/3 load, 2/3 loads, full load. And he had somewhere, I want to say 95% of his time was on full load.
Wow.
So there's your two extremes. One person, no full load, short run times, never got hot. 7 hours later, didn't work. Somebody else pushing 19,000 hours with not an issue.
So there really is two sides to this. There is the altitude question, which if you go above certain altitudes, 4,900 feet, let's say for the air top 2000s, you're going to have a richer fuel mixture. This is going to result in more carbon buildup, but that's going to take a while, and it's going to be mitigated by the other factor, which is the load. So if you're running that heater at a higher load, then you're going to have less carbon buildup because it's going to be working harder. Would that all be a fair statement?
Yeah, it generally is. It's safe to say that a heater that's working hard is burning hot. If it's burning hot, it's burning cleaner. Now, like you said, the altitude comes into play, fuel type comes into play. So we know there are people who are running the heaters above 4,900 feet. We know there's people that are having problems with that as well. That's why we say 4,900 feet is the engineered in limit, especially for the gas. We tend to stick pretty hard to that because we really are trying to give the end user the experience that they purchased. They wanted a heater that's going to work all the time. We're trying to really make sure that they get that bill of goods.
And so just, I know personally dozens of people who use these heaters at higher altitudes, all the time. And the only problem I hear is not that it doesn't work, is that they do at some point get a carbon buildup problem. What can you do? Well, let's go back to the timing question. If you're spending a day or two at high altitude, probably doesn't make any difference because it's not long enough, I would assume, for any buildup to occur or any substantial buildup. I'm sure you can't put an exact time frame on this, but what do you think it would take to do substantive damage in terms of carbon buildup? Are we talking 2 weeks or 2 months or 2 years for it to actually show something?
Typically, and again, like you said, there's no hard and fast rule, unfortunately. But we always say if it's going to live at altitude. So I always tell people, if you're going to go skiing for a few weeks, use your heater. Now, when you get back down to altitude, if you were up there for a long weekend, just run it for an hour or two. If you're up there for a few weeks, maybe run it all night long on high. Open the van up, let the hot air out. Wouldn't be a bad idea too if you are at altitude for a few weeks and you're going to run down the mountain to have dinner or something. Run the heater when you're down lower, just help offset that as much as you can during your trip. Because there's so many factors. We unfortunately can't say this amount of time at altitude means this amount of time running at lower altitude, but a few hours minimum on high.
So one of the things you'll see is if you had that experience and you wanted to run it after being at altitude, the heater will actually blow the carbon right out the exhaust pipe. So as you've got it running, if you look on the ground where the exhaust is blowing out, you'll see little black particles of carbon if there was any in there. So running it on high, like Tracy is saying, it's really like a purge. You're moving the maximum amount of airflow through there to blow any chunks that are in there loose and get them out of the heater. You want them out of the heater, and that's where they come out.
Okay. And so the real solution, if you're going to be at high altitudes if you live at high altitudes, as you said, Tracy, is probably to step up to the larger heater, which is the next largest heater, I believe, is the Evo 40. Is that right?
Yeah.
And as I understand it, the reason it's more capable at higher altitudes, even with the physical limitations or the physics limitations of gasoline, is that it's just bigger. So there's more airflow, there's a larger chamber, therefore everything kind of has higher capacity in a simple way.
Yeah.
And I would ask you, Scott, let's say you want to keep the smaller heater, it's more affordable. You're not going to be at high altitude a lot, or even if you are, let's say you want to repair it. Let's say you do get a carbon buildup problem. How are you going to know about that? Like, does it stop working? And then also, is this something you could fix yourself? Like, could you buy a replacement burner, or, what options are there for that?
Well, there's quite a few options for repair parts. Webasto's got a pretty significant catalog of repair parts. You can buy practically any part that it goes to make the heater as a separate component, from the plastic case pieces on the outside to the guts of the heater. It's actually a fairly simple device with a fairly technologically advanced control system on it. As far as taking care of any maintenance inside the heater, you really would need just your basic gasket kit. This is an Airtop 2000 gasket kit. It's got a couple gaskets plus the new rubber seal that goes on the bottom, because anytime you remove the heater, you want to make sure and replace that seal, keep it in good condition, because you want any exhaust fumes outside. You don't want them inside the compartment with you. So always replace those seals if you remove your heater. So you need to remove the heater, take the bolts out, separate the pieces, and physically clean the carbon from inside if there's any in there. If you have any buildup in your burner, this is a burner, small device. The bolt holes around the outside are match up with your gasket, same bolts that hold the halves together. You can physically clean it. If this mat in the middle is damaged in any way, you want to replace the whole burner, but it is possible to clean them. And you can get these as replacement parts. They come in a couple different varieties, with or without the other electrical components that go on there, glow plugs, flame sensors. So they're relatively easy to replace. You do need to be careful when you're putting everything back together. Make sure you've got clean, flat surfaces, because here again, you want a good seal. If you don't have a nice clean surface for those gaskets to seal, you're going to be leaking gas inside the operator compartment with you, and you don't want that. We don't want that. So if you're anywhere near a local authorized Webasto distributor, you can check the distributor locator, and if you don't feel comfortable doing it, call them up, go to their shop, see them. I'm sure they'd be glad to talk to you about it. Take it in there. They can get you the parts you need and get you the service you need if it's not something you feel comfortable doing yourself.
And I understand that you actually you can't just access this burner from the top of the unit. If this is installed into your van, you're going to have to remove it because of those bolts that you mentioned that actually connect through the gaskets.
Correct.
Mounted.
There's bolts that hold the two halves of the heater together, and then there are 4 studs on the bottom of the heater that hold the heater to the mounting surface. To disassemble the 2 halves of the heater, you'll have to remove it from the mounting surface. So the heater will have to come out of the vehicle. If it's behind cabinets or in some sort of enclosure, that, that could be difficult. A lot of these are underneath seats in vans, as you know, so it's possible you might have to remove the seat again to get it out. But again, once you have it out, it's not that hard to disassemble. Just be careful with what you're doing. Make sure everything is clean and dry and you got good sealing surfaces when you put it back together. And most people with an intermediate level of mechanical skill can handle this. Just be careful. And again, if you're not confident doing it, hit the distributor locator, find a distributor near you, and I'm sure they'll be glad to help you.
And Tracy, if you did have, we're really talking about worst case scenarios where you're running the heater at altitude for pretty long periods of time, not running it at full load later to try to clean it out. So, if you get into this kind of worst case scenario, and you've built up the carbon, you can imagine this burner full of soot, like you described from that customer of yours. How do you know that that's happened other than soot coming out of your exhaust? Does the heater just not turn on? What are the symptoms of that?
When you get to we'll call it critical mass, the heater is just not going to start. You're probably going to smell raw fuel out of the exhaust because fuel isn't being burned. And in some cases, it's not too uncommon to actually get raw fuel dripping out of the exhaust pipe because the fuel goes in. Now, Scott showed that burner mat. The fuel gets pulsed into that burner mat and then it spreads out in the burner mat in a little like a star-shaped pattern so it can evaporate off. Well, if there's carbon inside or even on top of the burner mat, but especially in that burner mat, the fuel doesn't get evenly dispersed, doesn't get burned, and it runs down that burner that he's holding, runs into the burner too, and eventually makes its way out of the exhaust pipe. So if you smell raw fuel, maybe you see raw fuel. In some cases, you're probably going to see heavy smoke coming out of it. That's a good indication. And you'll also get a fault code at some point. The two most common fault codes, well, I'll say the three most common fault codes that people see are F01, F02, F03. F03 is easy. It's a voltage issue. So check your battery, check your connections. But F01 and F02 are we're going to call them fuel-related faults. F02 means there was a flame failure. So the heater saw a flame at some point, and then it went out. F01 means it didn't start. So real quick, what to look for in those two situations, F01, F02, I always tell people, first thing you look for, especially if it's a brand new install, especially if it's DIY install, is make sure that you use the Webasto supplied fuel clamp or a fuel line and fuel clamps. The fuel line is a very specific inner diameter because again, every time that pump pulses, it's delivering a specific amount of fuel. Well, if the fuel line goes from a 2 millimeter ID to say an 8 millimeter ID, that's a much bigger volume of fuel. So that poses a problem. So make sure the fuel line, fuel clamps are correct. Make sure the fuel clamps are tightened. And I'm sorry, I should have brought a clamp with me. Our clamps are not like a worm gear style hose clamp. As you tighten it, it kind of cinches like this. Ours have two tabs that a screw passes through, and those two tabs have to come together and touch because those clamps are sized specifically for our rubber connectors. And they actually have a 180-degree clamping force as opposed to the worm gear clamps that actually they squeeze on two opposing sides. Anyway, you'll get a better seal. If those are loose, you'll leak air in to the fuel system. And I'm getting off the carbon topic here, sorry.
No, it's very interesting. Yeah.
My tech coming out. So make sure that you're using the proper line, make sure you're using the proper clamps, make sure the clamps are tight. So that if you see an F01 or F02, if you have a carbon issue, you're probably going to most likely see F01s all the time because it's not going to start. If you go outside the van, look for smoke, smell for fuel. And if those are the case, then and your fuel clamps are tight and your fuel line is proper, then yeah, you're going to want to consider the fact that you may have excessive carbon inside.
One last thing on this high altitude mode. I know some of the competitors out there advertise a high altitude adjusting controller, I believe it is, or other techniques. How can they do that? Do you know anything about the differences, and is Webasto looking to have such a feature in the future?
I don't know how they can do it. Honestly, I don't even know what they claim to do. I've heard of these high altitude kits. The problem is, I think I talked earlier about how it works. The pulsing of the fuel pump, you're spacing it further and further out. Well, at some point, you can't have a flame anymore. The flame burns out from when this pulse enters to when the next pulse enters. So yeah, I have no idea how they can do what they claim to do. I'll leave it at that. And as of right now, I don't know if Webasto is coming out with anything high altitude for the STC. I guess time will tell.
Okay. All right. Let's switch gears. A lot of people notice, and I noticed this when I first installed my heater, that anytime that I have the rheostat controller, anytime that's on in any place on the dial, the fan is running, even if it's very, very slowly, very quietly. And I would have expected the fan only to be running, let's say, when it was actually heating, but it seems to be running like constantly. So can you just tell us why that is and what the function of that is?
Sure. Anytime the heater is in an on state, the fan runs. And the reason is to circulate air. So on the AirTop 2000, well, any of the AirTop heaters that have the rheostat dial, the temperature sensor is in the heater housing itself in the case. So it needs to circulate air so it can sample the air that it's trying to condition, not from the living space. So it's going to run real slow. Now it's really slow as far as draw, just those who are concerned about their batteries. When it's on that low speed, I actually tested it myself. You're looking at about 6 watts. I'm looking at my notes here to make sure I'm not misspeaking, but I want to say it was half an amp, 6 watts on that. I'm going to call it idle speed. So it's very, very, very minimal draw. Yeah, and it's to sample the air temp. And if you're using the smart temp, which has the temperature sensor within the smart temp housing, it's just circulating air to keep air moving, so you don't end up in a little stagnant pocket of air. It's just giving you a more accurate measure of the air temperature.
Okay, so that is by design, and that all makes sense. And what you said about the temperature sensor being inside the heater unit on the air intake side, I think is kind of the answer to my other question, which is, I noticed when I use the rheostat controller, it doesn't seem to actually reflect the state of the temperature. And I guess that's because the temperature isn't being sensed or noticed or monitored at the controller. When you have the rheostat controller, it's actually being monitored at the heater level. Is that right?
Yeah, that's exactly right. And for that, in that aspect, I actually like the rheostat controller quite a bit, because you're very, very open as to where you put it. Right. The reason I say that is the smart temp has its temperature sensor, again, inside of the housing of the smart temp. There's little holes in the bottom to allow air to circulate. So therefore, if you have your smart temp mounted close to a window or a door, you could be getting cold draft coming in from that window or door. Or if you're in a situation, or if it's mounted in a place where it's getting the direct heat output from the heater, you're getting wild swings. Maybe it's you have it set at 68 degrees, the air outside is 10, you're getting that cold air coming from in the window, the heater comes on. Well, now you're getting blasted with very, very, very warm air from the heater. It thinks it's up to temperature already, and it just keeps fluctuating on and off, which is, it's not comfortable for the occupant. So the rheostat kind of eliminates that problem, but of course you lose the timer function and the display and all that fun stuff.
Right. So Scott's showing these, which is handy. So the by default, you get that the one on the left there that he's showing, which is the rheostat controller. That has no temperature monitoring capability. So if you use the rheostat, that's actually built into the heater, which if the heater is at ground level, which it often is, in a van, then you're going to get, it's going to be slightly off. It's, in other words, that air down there is going to be much cooler than if you use the smart temp. By contrast, not only does it add all the smart features, like, having a schedule and so forth, it adds the capability to do room temperature sensing wherever you place it. But to your point, Tracy, you should place it somewhere smart. Otherwise, you're going to get these weird sort of temperature swings or what have you.
And inside of something the size of a Sprinter Transit ProMaster, it can actually be a challenge to put that smart temp away from windows, away from doors, and away from the direct flow the airflow from the heater. So it can be tricky.
Okay.
Also, I wanted to mention, if you are using the rheostat, because it does rely on air circulating through the housing for its air regulation, its temperature regulation,
Mhm.
it's critical to use a return air duct. A lot of folks I've seen, they'll put it back in the garage area with an
Mhm.
open return air intake, I'm going to call it. So that's actually pulling air from the garage area. And usually those are fairly well sealed off from the interior.
Right.
So it could be a few degrees. It could be 10, 15 degrees cooler. Well, that's what the heater's reading. So
Got it.
you may be asking for, a certain temperature, you're not really getting it. On that rheostat dial, we tell people that straight up 12 o'clock is roughly 70, 72 degrees. But we always say that isn't necessarily the case, because that's just a resistance measurement you're sending back to the heater. It's going to depend on the temperature you're reading. So yeah, return air duct is critical. And also make sure your return air duct and your supply air duct, and this is all covered in the manual, aren't so close that the heated air just gets pulled right back into the return air. That's going to give you a false reading.
Okay. And you can also, correct me if I'm wrong, there's a room remote temperature sensor that you could use that is sort of I guess it's somewhere in between the rheostat controller and the smart temp, where it adds room temperature sensing wherever you put the sensor using the rheostat controller. Is that right?
Yeah. Yeah, it plugs into the existing wiring harness. That's all you have to buy, is just the external sensor. And it's, I can't remember the size hole you drill. It's a very small hole. The actual temp sensor itself is maybe the size of a nickel. So it's not big, it's not obtrusive. You find a panel somewhere to mount it, and it's going to take your sample from there. So again, remember, it still kind of follows those same rules. If it's mounted next to a window or a door, or mounted in the direct flow of heated air, it's going to give you a little bit erratic readings maybe.
So
Right.
pretty much between the two, you have the rheostat with the temperature sensor, or you install your smart temp kit, and that gives you the smart temp with the remote temperature sensing functions inside here.
Right.
So this with the remote sensor, or this by itself.
Got it. Okay. Awesome. So let's switch gears again. So we'll talk about the Russian kits. Lots of people in the Vanlife community have purchased Webasto heaters from Heaters for You, which is based out of Russia, because their prices are kind of ridiculously low. In fact, I purchased my first Webasto heater from Heaters for You, and I've learned a lot about that situation, which I've updated my blog post about, and I'll link that in the description to this video. But I'd like to talk a little bit about how and why that's happening. So I have this theory that Heaters for You must be able to purchase their heaters super cheap in order to be able to sell them at that low cost and still make some kind of profit. So obviously this is hurting US distributors like Scott, like myself. Is this a situation that Webasto is aware of, and are they concerned about it? Are they doing anything about it? Like, what's the next step for the perspective from Webasto on that phenomenon?
Well, I don't know why. I don't know how they're able to sell the heaters as cheap as they do. I have my theories, but yeah, they're just theories. I don't know. The biggest issue, really between the heaters purchased outside of North America and those purchased in North America, there's a couple things. The heaters outside of North America are oftentimes, there are some versions of a specific model. I'm trying to think of the easiest way to explain this. I'm sorry, it's just not terribly easy to explain. So you have the AirTop 2000 STC. Some of those models may have different programming for something outside of North America. And sometimes that also includes certifications, for safety certifications, maybe emission certifications that simply only apply to North America, or they only apply to European Union, or wherever. So if you buy a heater from outside of North America, you're getting, from our perspective, an unknown set of programming, just because I don't know that here in North America. It's not our product, essentially. The other issue though, really, and to me, the biggest issue is kit content is different. And I don't know the specifics of that. I think Scott has probably dug into that a lot more than I have, but the warranty. So Webasto is, I'm going to admit, I think we go above and beyond. Of course, I'm going to say that, but I really believe we go above and beyond in the warranty aspect. We want to give you a warranty if it's at all possible. Now, if the heater comes from, you said Russia, so if it comes from Russia, we're going to support you. If you call our tech line, we're going to support you, whether you're the end user or if somebody has showed up at your shop with a heater that has a foreign, I'm going to call it foreign wiring harness you're not familiar with, you don't have pinouts. We'll help you every bit as much as we possibly can. If it's under warranty though, the end user is going to have to pay for that service and then take their receipt, take their documentation to the place they purchased the heater from to get reimbursed. So that's headache for the customer. Sometimes right there, that's enough of a reason just to simply purchase one here. You're gonna get much better support, faster support, and your warranty process is gonna go a lot easier.
Going back to the top of this conversation where we began with warranty, having somebody in North America that can supply you parts, service really does make a big difference. And one that understands and will fully support a DIY build in a camper van is also pretty substantial. That's the space that we're trying to fill, and the value that we're trying to provide out there in the community is content like this, the kind of support that you might need as a DIY installer. So that warranty does have real value. I didn't realize that a year and a half ago when I first discovered these Russian kits. So I think it's important that we unpack that for people who are trying to decide. And the other thing is, correct me if I'm wrong, Scott, you're the expert on this too. If you have like a wiring harness from that Russian kit, that's a European model, basically. It's not going to be compatible with all of the parts that you would buy, let's say, from us, like the remote temperature sensor or something like that. Is that right?
That's correct. There's the product is essentially the same product. It's the air heater. They look the same, they operate the same, but a lot of the parts are different. And Webasto is a global company. They manufacture stuff on multiple continents. They sell into different markets, and like Tracy alluded to earlier, they have rules and regulations in each one of those markets that they have to meet. If they're selling product into Asia, they do not have the same noise pollution regulations. They don't have all the other regulations, safety issues that they would have to deal with by selling a product into England. And then those issues would not be the same as the issues they have to do with selling product into North America. So Webasto, because they are global, they do have to tailor to those markets if they want to do business there, because they have to follow the rules just like any responsible business would. So the product you get from there is fine-tuned for that market that it was meant to go to. And there are some things about that that may make it not suitable for this market. There are differences in the kits. If you buy a gasoline kit for the North American market, it is going to come with some parts that are not in we're talking about Russian kits. So not in the Russian kits. There's no mounting plate in there. There's no mounting plate gasket in there. There's no fuel filter in there. You need to have a fuel filter. You need to have a fuel filter, period. You're not going to get one in the kits. You're going to need to buy one extra. You can mount that heater without the mounting plate. It's more difficult. But all those parts are available as optional parts, and they're one of the things that's universal between the heaters. However, to your point, the wiring is physically different. The European wiring will not connect to the American Smart Temp controller. Number one, there's fewer physical wires in the harness, and the programming of the heater is different. It won't support the functions. So they won't work together. If I get a heater in here that I need parts for, I can look up any part on any heater that's designed for this market. That's what we do as an authorized distributor. If I get a heater that I need parts documentation on because I can't find it, I would call Tracy and say, hey, I've got this serial number, this model, I'm looking for XYZ. And he would look it up and say, that's funny. It doesn't show up in the system. Hold on, let me check something. Oh, wait, I see. That's European product. I can see it, but we can't get it for you because it's not supposed to be here. Pretty much how it
Yeah.
works. It's not an issue of whether we want to or don't want to help you. It's very, very largely, we can't help you. We can't.
And if you are able to order a part, it can be 4, 6, 8 weeks out because it has to come, we have to order it from Webasto Germany or Webasto Russia, whoever. Yeah, so that is a bigger issue. So if a customer comes in and they have maybe they frayed a wire during their install and they've wrecked their wiring harness, well, Scott can't just order a wiring harness. He either has to order the North American harness and the North American controller, or he has to wait who knows how long to get the native part.
Yeah, understood. Okay, yeah, definitely understood. And I think, Scott, you're going to be making a video that compares what you're going to get, right, in a Russian kit versus a kit that you would get from us. Like you're actually going to open those boxes and do a piece-by-piece comparison.
That's correct. We just recently filmed that. The intent is to put that on our YouTube channel, and we've got a Russian kit that we purchased from a popular online platform. And we have one of the North American kits we sell, the medium duty Airtop 2000 STC gasoline kit. And we set the boxes side by side and take out one piece at a time so you can see exactly what you get in this one, exactly what you get in this one. I don't want to give away all the surprises, but it's, it's interesting. It's interesting. The goal is to try and inform the consumers so they know what they're getting into before they get into it. Yeah. Some of the stuff, if you buy it, folks, once you spend your money is spent. You've got what you got. If you have a problem, it's unfortunately going to be your problem.
Yeah, we touched on a lot of this, but I think it's worth asking very specifically. What do you recommend people do as routine maintenance? So you've got an Airtop or maybe an Evo 40 heater. I guess those are both Airtops, but the Airtop 2000 versus the Evo 40. What should an end user do, customer do, like on a regular basis to make sure this is maintained and running as well as possible?
The only thing that we really outline in the manual, and these are the two things that are necessary, is that running it every month for 30 minutes on high, 30 minutes on high. That's pretty important, pretty critical. And then Scott mentioned the fuel filter. You want to replace the fuel filter annually, at least. If you're in a situation where you've got some nasty fuel, you may want to replace them more than once. Having one or two of those in your van is a good idea. On the note of that fuel filter, though, that fuel filter looks very, very similar to a filter you can pick up for really, really cheap at a small engine shop, maybe. But the critical issue is the filtering media inside. Ours is a metal media that, of course, isn't going to break apart. The cheaper ones are a fiber, and the fibers can and do break loose and go upstream. And the next thing upstream is going to be your fuel pump, and those fibers get in the fuel pump. And the fuel pump is essentially two opposing solenoid valves. So when that fiber gets in there, it's going to clog up the pump relatively easily. So get the proper fuel filter, the proper Webasto fuel filter from a dealer, and swap it out once a year, or again more often if you know you've got some dirty fuel somewhere or some sediment in your tank.
Got it. Okay, well that's pretty easy. So simple
along
stuff.
Those lines, I don't even think I can get it close enough. This filter does have a directional arrow on it. It is very hard to see even in person. So if you're replacing one, make sure you get the direction right.
Yeah.
Right.
And tighten your clamps when you're done.
Yeah, your clamps, your special fuel line clamps. These are the ones that Tracy mentioned earlier. It's not the same as a worm drive clamp. You can see there's a little bit of difference in the way they look. So don't go to the hardware store.
Right. And those are included in the kits. So it's not like you have to buy those separately.
Right.
Everything you need to hook up to the fuel tank is included, except for the tapping kit. But we can sell you a tapping kit, or those are available in many places. Okay. So I think this is a quick question, but a lot of people are drilling holes in the exhaust tube that comes out of the combustion air exhaust. And that's that stainless steel tube that you direct to the sidewall of your van. What's the purpose and intent of drilling those holes?
So ideally, you want from the heater to the end of the exhaust pipe, you want a gradual down slope because you're going to
Right.
get condensation in the pipe. You want to let the condensation drain out. But we know that isn't always possible. Sometimes you have to have a bit of a trap. And if so, at the lowest point or points, if you have more than one low point, you want to drill roughly a 4 millimeter hole at the bottom to let the condensate drain out. And you want to do that on your exhaust and also on your combustion air intake if you have a low point.
Oh, okay. That's interesting. I've
Although
only personally.
I'm sorry, if you don't, the water will collect in the exhaust pipe. And in the warmer months, the heater won't be able to blow the water out. It'll just create a stoppage. In the cold months, before that even happens, the water will freeze. And now your 22 millimeter pipe is now much smaller because the ice caused a restriction and the heater can overheat.
Will that log fault code, Tracy?
Yes. It's a good thing is almost anything that's not right with the heater will throw a fault code for you, which is a good thing.
Yeah, we should probably link to some kind of table of fault codes, right? I believe that's in the manual, but
There is a table of fault codes in the installation manual that you get with your kit, just to use for your reference. It's a dozen or so fault codes that are in there. There's not much more than that to the heater. It's not like a car where you can have many, it's 10 or 12 different fault codes for all of the operations of the heater. So not over.
Right. And if you use the rheostat controller, those are indicated by flashes of the light, if I remember correctly. Yeah.
So,
So you want to count the slow flashes.
See
Count
that
the slow flashes, and
See that.
and that'll correspond. Okay. If you have the smart temp controller, which I don't have, does it do the flashing or does it do something on the screen that tells you a fault?
It does both. Those two, you may not be able to tell, there's two lights on either side of the screen. Those will flash fast and slow, count the slow ones, but also the screen will say F01, F02, whatever the case may be. And yeah, there's fault codes in the install manual. You can always call a dealer, ask for help. You can call our tech support line. We would even send you the fault codes. Honestly, I don't remember if they're in the operating guide or not.
With the smart temp, it displays the fault code, but it also displays the description of what the fault code is.
Yeah, it'll give you a couple words. It's enough to give you an idea of what's going on, and it's certainly enough if you call it, call your dealer, call Scott. He'll know, okay, this is where to look. It isn't necessarily this is the problem, but it's where to look.
Right. So with the rheostat, that light in the middle flashes, in that case, you would need the list out of the manual to decode the flashes to tell you what the fault code is, whereas this gives you the short description right on the screen, as well as the fault number.
And how hard is it to do that upgrade, Scott? Like from a wiring perspective, if you had the rheostat and you're like, wow, I'd like to have that fancy smart temp controller.
If you have a rheostat with your air top already installed on your vehicle, what you want to do is buy the kit. There's an upgrade kit. Make sure you get the one for your right heater, because there's a kit for the ST, which is the older heater, and there's a kit for the STC, which is the current heater. The kit comes with an additional wiring harness that you will use, as well as your original heater harness and the smart temp control. So you get this control plus another harness. The smart temp will plug into the new harness, and the new harness at this end will plug into the old harness. And then at the opposite end, where the heater is, there's a connection point there, and there would currently be several unused connectors at the heater end of the main harness. That new smart temp harness will make connections at those points as well. The connectors are matched. You can't mix them up. They're very easy to identify. White connector to white connector, black connector to black connector. There's one connector on this end that's got 8 pins on it. It's the only one, so you can't get it wrong. And then you have to make your power connections using the same supply system that you have the main heater on. That's pretty much it. The big thing is, if you've got your original wiring harness running behind paneling, you'll need to run your new harness kind of in conjunction with that. And that can be kind of a pain point depending on how your paneling and insulation is.
Right. Yeah, that's a good point. So if you think you're going to want that, it might be worth springing for the upgrade when you're doing your builds, or at least leave some conduit or something in those walls to kind of pull through the new wiring harness components.
Correct.
Okay, awesome. Well, that's all the questions that I had. Tracy, is there anything else you want to like impart to this community of people who are using Webasto products and camper vans? Something that you know you'd like to share that we didn't cover today?
Really, the only thing I wanted to mention is something I think people don't realize, that we have a very good technical support website, especially if you're after hours. You know, your best bet typically is to call one of our distributors like Scott, because you're going to talk to a human. But we do have a technical support website, which is techwebasto.com. Our information's on there. Also, we do have an 800 number, 800-860-7866, which is manned 8 to 5, Monday to Friday, Eastern Standard Time. And that's, of course, there's no charge for that. Call in, you get one of the techs on the line, will help you out. If you're looking to find a place to get one installed, we can help you find a place to get one installed, direct you to our dealer locator. And this is really just a blanket statement that goes for anything. Beware of what you read on the internet. There's a lot of misinformation, and it's so awesome that you guys are really trying to nip that in the bud and head it off, so we can really try to get the correct information out there. I've seen videos and read blogs where somebody will tell you, you know, to adjust for high altitude, just ground this wire, turn this to 11 o'clock, and then a few minutes later, you're good to go. Well, you know, maybe that worked for this guy the one time and his heater ran for a day and he thought it was a success, but did he update it 6 months later to tell you that his heater carboned up or, you know, whatever? So there's plenty of resources out there. Call your dealers, call the place you bought it from, get the real information, get the correct product the first time. So you don't really ever have to revisit this. Put it in and then just run it, enjoy it.
Yeah, I agree. Boy, you know, there's a lot of weird information out there, kind of anecdotal stuff. So thank you so much for answering our questions today. I think this is going to go a long way into, you know, putting real, solid, reliable information out there. Hopefully we can do it again.
Sure. I'm up for it.
All right. Awesome.